Let's take a look at a theoretical home in Lansing, Michigan, which is in climate zone 5, and like much of the Midwest has a cold, moist climate as defined by the 2009 IECC. The home has a basement and vinyl siding. We'll assume the soil is expansive or collapsible, and the home has a sump pump. So determining these characteristics will help us figure out which of the 21 items are actually applicable in this case. The first thing a builder should go through and do is walk through the requirements, cross off all the items that don't even apply to the home. They're not even relevant. So let's do that here. Turns out that 2 don't apply. Item 1.4, which addresses capillary breaks for crawl spaces, because we're dealing with a basement here, not a crawl space. And item 4.3, which addresses vapor retarders in warm, humid climates. Again, in this case, we're dealing with a cold climate. So without having done anything at all, we've already reduced the requirements from 21 to 19, right? Cross those off the list. Now, the second thing you want to do is go through the requirements again and look for items that can be met just by not doing something, because those are like basically a freebie, right? And in this case, there are 4 items that are things not to do. First, item 1.6 prohibits class 1 vapor retarders from being installed on the interior side of air permeable insulation in exterior below grade walls. This is a little tricky. We'll come back to explain the details of it, but it's easily avoided. The second item is item 4.1, which prohibits wall-to-wall carpeting from being installed within 2.5 feet of toilets, tubs, and showers. Hopefully that was a decision that you were already making, but it's in there just in case. Third, 4.4 prohibits building materials with visible signs of water damage or mold from being installed in the final house. And fourth, item 4.5 prohibits framing members and insulation from being enclosed if they have high moisture content, right? In other words, if they're wet, you need to let them dry out first before you drywall them in. Again, as long as you're careful not to do these 4 things, then we've already addressed a quarter of the applicable requirements. So without having done anything at all or adding any costs, we've already reduced the requirements from 21 items down to 15. And many of those 15 requirements are things, possibly all of those are things that the builders are already complying with. You know, they're not just best practice, they're really standard practice at this point, or they should be. So we won't go into detail on these items on this slide, but we'll in the next section. Just take a quick look, and I think you'll see that these are all pretty achievable items. Okay, so before we move on, let's just summarize. For this sample home, over a quarter of the requirements were either not applicable or were things not to do. So that means there's just 15 items that we need to make sure we are meeting.
Elliot, real quick, can you confirm that when you say expandable, collapsible soil, are you saying, and the way we usually say it is well-draining sandy soil. So is that the same as well-draining sandy soil or the opposite of well-draining sandy soil?
It's the inverse in general, although okay. I actually would want to take this with a grain of salt, because I actually will want to follow up on that, and I'm not 100% sure if the Venn diagram is completely aligned. In other words, I think that expandable and collapsible may be a more limited definition.
Okay. Do you have any more further discussion here on identifying those? Because if you do, I'll let you get to that. But if not, I wanted to kind of ask a follow up there.
We will come back to it. So
Okay.
in a few slides. So why don't we come back to that, and then we can talk about it a little bit more at that point. Okay, so and that's a great introduction, because we're going to jump into each of the most of the remaining items one by one. I think we're going to cover something like 11 of the 15 in detail here. And if you do have questions on any of these as I go through them, this, great time to raise your hand or type a question in the chat box, and we can go into any kind of follow-up questions while we're on the topic. Otherwise, we'll come to it at the end. Excuse me. Okay, so let's get into it. First item on the list is 1.2, and that requires that backfill has been tamped and that the final grade is sloped a ½ inch or more per foot away from the home for at least 10 feet. So the purpose of sloping that final grade, right, is to direct water away from the home's foundation. As you may know, there are other requirements that help protect the foundation from water damage, right? Like, it does have to be a waterproof foundation in the first place, but we want to make an effort to keep water away from the foundation in the first place. That's really your best insurance, is to just get it away from the house, so it doesn't even have a chance to try to penetrate the waterproofing. The additional requirement to tamp that backfill is important to ensure that the slope is maintained over time. So let's just kind of look at that really quick, right? When the backfill is first added around the foundation, it will typically have voids and other air pockets in it. That's kind of the picture on the left. So even though it may be properly sloped and it might look to your eye like, oh yeah, great, that's got a nice slope on it, that's what I want to see, it's going to settle over time and slope backwards towards the home, defeating the purpose of having it sloped. So on the picture on the right, tamping it down, tamping the backfill helps eliminate these voids, so that you kind of get that slope in the long run. There are a few exemptions to this requirement. The first exemption is for homes that have non-settling compact soils. The compactness of these soils reduces the voids and therefore minimizes shifting and settling that could alter the slope. And I actually want to pause here, because as we were reviewing the presentation this morning, I realized that I think this map is a little bit of a red herring, and you should pretty much ignore it, because when we're talking about a non-settling compact soil, that's basically a specialty backfill, either specialty material or specialty process, that's going to meet that definition. And it's basically, a special backfill material that does not require tamping down, because it is already, it's basically got no air to lose. It's already, by nature of the way that it's made, going to be like fully compacted. So like one example that I know of this is a liquid soil application. So again, this is generally speaking not having to do with the soil that you've dug out and put back in. This would usually be if you've got some special backfill material that you brought on site to do this, so you could avoid the tamping step. I think we can probably leave it there. I think the other examples, if you have an example of this and you're wondering if it does apply to our program, I think it's probably best to contact us to double check if you're unsure, because it's a little bit of maybe a case-by-case situation. The second option is that you have is to wait for the backfill to settle over time and then revisit the home to provide infill and final grading. So you can kind of let nature take its course. You expect that it will, whatever slope you had originally put in there will be reduced, or maybe even go down the other way, and you'll come back and you'll add some additional on top. You'll see basically the same thing happening like I just described, and then again you're going to come back and add in to complete the triangle, so you kind of reestablish the slope there. To do this, you are going to need to schedule a site visit after the home has occurred, for example, after the first rainy season. And when I say site visit here, I mean sort of on the part of the builder, because homeowners will probably be living in the house by this time. It's going to be a little bit more difficult to do. Some builders already routinely visit the site after closing, so that may or may not be an issue, but others would prefer not to revisit the site. So this option may not be as appealing. The other exception to be aware of applies to homes with space constraints. So remember that this item requires the slope to continue for at least 10 feet away from the home. Some homes may have space constraints, like small lots where they don't have 10 feet on the side of them. And so in that case, as an alternative, if you're unable to slope the final grade for at least 10 feet, you can install swales or drains, or a combination of both to carry the water away from the foundation. So it's basically 10 feet or as far as you can, but then it needs to go into a swale or a drain. So you'll see the image on the left shows a small lot where sloping isn't possible for 10 feet. And on the right, you can see swales used as an alternative.
Alec, can you quickly define what tamping is, how you do that?
Sure. Okay. I think anybody that's sort of installed a patio knows what tamping is, right? That's where you, if you do it by hand, you lift up a tamping tool and you drop it down, and you sort of do that all over that backfill material, right? In practice, there's the kind of vibrating tamping machines that are going to go along and vibrate along and push everything down. So that's the tamping process, right? It's just basically vibrating it, pushing it down with the weight of it, and sometimes in the process of that, you're going to kind of refine it as you go to add a little bit more soil in so that you do achieve that final slope by the end.
Thank you.
Yep. Okay, so let's move on to the next requirement, which is 1.3. Yep. So I got one ahead of me there. So 1.3 requires that a capillary break be provided beneath all slabs except crawl space slabs. The reason for these requirements is to prevent water coming up from the ground through the slab, which is very porous. Concrete's porous like a sponge, right? And then into the home. So the added moisture moving into that home, it can be bad for materials that are in direct contact with that concrete slab. And it can also cause the humidity levels in the home to rise. So even if it's not visible, it is affecting that kind of humidity balance in the home. And especially, depending on the water table and depending on where you are, it can be a very significant amount of humidity that is entering over time. So in the diagram here, you can see that a lapped polyethylene sheet has been laid down before the slab is poured. That's the right way to do it. That sheeting will act as a capillary break and block groundwater from coming in contact with the slab. The polyethylene sheeting must be at least 6 millimeters thick, or 6 mils, and as an alternative, you could also use 1 or more inches of extruded polystyrene insulation with taped joints. That's also going to serve as a capillary break. Now, note that this is not required for homes in dry climates, as shown here in 2009 IACC figure 301.1 and table 301.1. Probably we don't have anyone on the webinar in a dry climate, and our home in Michigan wouldn't qualify, but just, FYI, that exception does exist. So the next requirement falls under the category we noted earlier, items that are things not to do. Item 1.6 requires that class 1 vapor retarders not be installed on the interior side of air permeable insulation in below grade walls. Okay, so that's mouthful. So let's walk through each component. First, a class 1 vapor retarder is defined by the IRC as a material or assembly with a rating of less than 0.1 perms. And materials with a perm rating less than 0.1, that means they're very resistant to water vapor moving through them. So that's things like rubber membranes, polyethylene film, glass, and foil face sheathing, right? It's basically impermeable. It's extremely close to impermeable. If you take a piece of polyethylene film and you put water on top of it, it's going to hold that water. Now let's talk about how this applies to below grade walls, right? What does this requirement actually mean? So even when below grade foundation walls are damp proofed or waterproofed on the outside, nothing's perfect in life. And so there is always a chance that some moisture is going to be coming through that wall, through whatever crack or seam or flaw or development over time, leak, and trying to get in through that concrete. So knowing that, you wouldn't want to put a class 1 vapor retarder on the interior side of insulation in below grade walls. So think about the assembly shown here. Water vapor comes in from the ground, through the concrete, through into your wood stud wall with your insulation. And if you have stapled poly sheeting on the inside of that wood framing, that poly sheeting is going to block that water from going anywhere. It's just going to be trapped in that wood assembly, and the wood's never going to have a chance to dry, and it will be stuck there forever. And when wood just stays wet forever, it rots. So that's why it's a problem. That's why it's not allowed, and essentially what we're trying to avoid. So let's talk about some ways that we can avoid it, and we can do this the right way. Okay, in the first example on the left side, you see there's just no vapor barrier at all. We're just not installing anything in that class 1 vapor retarder. So that would just be concrete wall, bad insulation, framing, and drywall. Okay, so if you do that, water vapor can pass through the assembly just all the way through into the interior, adds a little bit of humidity into the interior. So that's will be something that the ventilation and the HVAC system is going to have to deal with. But ultimately, as far as that wall is concerned, that's kind of an acceptable situation. Okay, in the second example, we see a class 1 vapor retarder, the foil face rigid insulation directly on the wall, but there's no air permeable insulation in the assembly. So that's fine, right? Like basically there's nothing to rot here or be a problem. So we're probably wetting that concrete, but that's actually okay because that concrete is durable to wetness even over long periods of time without causing any durability issues. So in the third example, we see that there is a class 1 vapor retarder, but it is put immediately next to the concrete wall before the wood framing is built on top of it. And so we have a class 1 vapor retarder, but it is still just keeping basically the concrete wet, and it's not trapping any moisture onto the wood. If any vapor got through, it would still be able to sort of dry out to the inside. So that's also fine. There's other ways to do this. You can look up lots of details. These are just kind of 3 of the most common. The last foundation requirement is 1.8. And that's a requirement for drain tile to be installed at the footings of basement and crawl space walls. Level or sloped to, so this is the drain tile needs to be level or sloped to discharge the water to daylight or to a sump pump, and then surrounded with clean gravel and a fabric filter. That's also known as a French drain. The purpose of this requirement is to drain away water that might accumulate at the bottom of the foundation wall. And, even if you have the sloping right and everything, sometimes this is still going to be an issue in heavy rains, or if you've got some irrigation that's directly putting water in those areas. or if you've got changing water level tables, and so it's not even necessarily from right there, but it's just the general water table is kind of creating a groundwater right up against that foundation. So that's kind of the basic. Oops, sorry. So again, drain tile is a really solid bulletproof solution, but there is an alternative, and that's using a drain tile product that is pre-wrapped with a fabric filter. This type of product can reduce the labor on site required to manually surround the drain tile with gravel and wrap it with a filter. So let me just break that down for a second. The historical way to do this is you put the fabric down, you put some gravel in, you put the drain tile in, you put the rest of the gravel in, and then you wrap the fabric around. Okay, what I'm talking about here in the alternative is a drain tile, the round pipe itself, that comes pre-wrapped in a fabric. So it just kind of takes one step away from that installation process. So that is acceptable. Another option is a composite foundation drain system, or CFDS, that has been evaluated for use by ICCEUS, which is the International Code Council Evaluation Service. So it's worth talking about that for a second. That is a group, the ICCEUS, that evaluates specific products using specific standards to determine whether they meet the intent of a code requirement. And in this case, ICCEUS has a standard that can be used to assess whether a product can work as a foundation drainage system. The compliance reports are typically online, so if you'd like to use one of these products, just make sure that it's been evaluated by ICCEUS in accordance with ACC 243. So again, it's not just seeing the stamp on there because it might have been evaluated for something else. You need to look for AC 243. And it's also worth noting that the product must include a soil strip drain or another ICCEUS evaluated perimeter drainage system to be eligible for use. So again, that's kind of, we spent more time talking about the exceptions than the main rule. The main point is we're looking for a drainage system here to bring water away from the foundation. Okay, so that's the foundation. Let's move our way up the building a little bit.
Real quick on some foundation questions.
Please.
Well, I've got one, a previous one, but let's stick with the one we were just on. The comment/question was, often the soils report will make specific recommendations that are very different than what you show. And also the sump pumps are rarely needed, often will fail, thus creating other problems. Any comments on that?
I'll take the sump pump one first, which is, I would tend to agree that if you can do it without a sump pump, if you can slope it to daylight without a sump pump, that's usually better, right? Because that's a passive solution that doesn't require any mechanical equipment to work. So it's just simpler, it's more foolproof, and it'll probably last longer without any sort of maintenance. So that's great. The issue is that's not always possible, right, depending on the site. So that's just what's going to determine whether or not you need a sump pump. Okay, whether you have the ability to drain it out anywhere to daylight. As far as the soil report, to the extent that anything calls for more extensive drainage than we're calling for, then that's what you should do, right? Like we're just kind of setting the minimum bar here. To the extent that it's calling for less, that's probably feedback that I'm not sure we've really received. So I'd be interested in kind of seeing some examples of that and hearing a little bit more about that condition and what's going on there. And I think I'll probably leave it there with that.
And then follow-up is, I've seen foundations designed to handle the static pressure of wet soil without needing this type of drainage. Is there any alternatives like this that are acceptable by Energy Star?
Give me the The intro again?
So it's foundations designed to handle the static pressure of wet soil without needing this type of drainage.
We don't have, these are the exceptions we have for it. So we don't have sort of an exception for, that's basically what we're doing here is belt and suspenders. We're saying you need to waterproof the foundation, and then you need to also have a drain system here to drain water away from it. And so that way, if either fails, you're not sort of in a catastrophic failure. I can certainly understand the argument for saying why you only need belt or you only need suspenders. But again, we just kind of think it's a riskier place to be, and so that's kind of why we've set the policy as a general matter to require both. But if again, we're always open to hearing feedback on these requirements.
Okay. And then going back to the capillary break, is the PSI of the concrete matter for its permeability and affect the requirement for separate capillary break? So for example, some contractors suggest that a 5,000 PSI concrete is the capillary break.
That's a new one, Brett, to me, to be honest with you. I don't know if you have any background on that. That's a new one. In my experience, regardless, concrete is going to be porous, fairly significantly porous. So I'm going to be honest that I'm fairly skeptical of that, that kind of suggestion. But regardless, for the program requirement, it is definitely required to have a separate capillary break, I guess, unless again there was some sort of certification or something that that it was meeting that the class 1 requirement on it of being a vapor retarder. But or sorry, we're up in capillary break. Yeah, I can't remember if we explicitly call out the vapor permeability, but so I would say I'm skeptical of it. I would assume no. That in general you should be planning on putting a sheet down. But if there was some sort of classification available, some sort of a report or something, we could look at it.
Yeah.
But probably not.
Okay. And then just can I get you on record before we move on from foundation to say that if you just do slab on grade, then most of this hassle is just not even a problem.
Yes, definitely. Right. I think some or all of these, yes, absolutely. These are talking about, these are not talking about slab on grade. You get out of all of this hassle with slab on grade.
All right, thank you.
Yep.
Thanks for watching. Please continue to watch the next part of the session to complete the course and get your continuing education credits. Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.